In this video, we are going to discuss the very important techniques for string formatting. Even though most operating systems today are displayed mostly with graphics, we still have the necessity of formatting text in a manner easy to consume. If you were to look at even the simplest graphic display, if I bring up another program like Calculator, you will see even though it's a graphic-based environment, there is still plenty of text on this screen. We have like these indicators whether we're in hex, decimal, octal, or binary format. We have these buttons, and each of them have some text, sometimes a symbol, not directly a text value. But the point is, menus all require text. If I pop up settings, we have text in here. So we do still require a lot of text in our graphical environments. Let's start by creating some variables. We have an int called x, a double called y, and a datetime called dt. If we wish to output this to the console window, we could do so with some simple string concatenations. But when I print this, you'll see, okay, that's not very pleasing because we can't tell where one number starts and the other one ends. So clearly we have to do something to pad these values. Well, the simplest approach would be to put in some literal spaces as such. Now when we run it, we have things lining up. But what happens if we had another set of variables? I'll just copy these. And we'll say it's x2, y2, and datetime2, dt2. And I'll change the values ever so slightly. So there's still ints, doubles, and date times. But when I print this one out, again, not entirely pleasing to the eye. If you look at the numbers here, sure, we have left justification on these numbers, but then when we get to the decimals, typically you like to see the decimals lined up by the decimal point when you output things. And then the dates, you can see this one starts with a 2-digit month, this is a 1-digit month, and I could have made things even worse by, instead of saying 10-1, let's say 10-10. So now that's 2 digits instead of 1 and 1. By the time we get done, we're 3 characters off in justification between the two strings. This may not be a critical issue for many applications, but a lot of times when you display information in a tabular format like this, you want the columns lining up. So we have some choices here. Well, some people say, well, we'll just use tabs, because tabs will line things up nicely, because tabs will go to the next column evenly divisible. By default, it's 8. So we run it again. And yeah, we have left justification again on all the values, but we still didn't accomplish the what we wanted to with the lining up the decimal places for the second values, and the dates are still kind of funky. So we probably need a different technique. And this is where string formatting comes in handy. I'll create a variable called output, and I'll set it equal to string.format. And string.format accepts a string followed by a number of parameters, which typically correspond to variables or literal constants. I'm going to use x, y, and dt as my first set of values for the string format command. And then I have to design what I want the output to look like inside these quotes. So I could do output, because we know we want that literally in the output. But then I need to find a way to get these x, y, and dt values into this string. Well, there are value substitution sequences that I could use that give me that capability. So when you have a curly brace with a 0 inside of it, that corresponds to the first parameter in this list. The 1 corresponds to the second one, and the 2 corresponds to the third one. Now, I'm calling this first, second, and third, completely ignoring this parameter here. Yes, that's technically the first parameter to string.format, but when I'm referring to the 0, 1, and 2 here, I mean after that format string, this is the first, second, and third parameter. 0 based meaning 0, 1, and 2. And you can use 0 as many times as you want. So if I wanted to, I could print out 1, 2, 3 three times in a row as such. There's nothing wrong with that. And the order that we use, the 0s, 1s, and 2s, etc., also doesn't matter. So they don't have to always be in the exact same order that they show up in the parameter list. Just be cautious and don't use something out of range. 3 does not represent a variable because that would be something off here. We don't have that. We only have 0, 1, and 2. So an attempt to use a 3 here would yield an exception. Okay, let's start with this and see what the output looks like. Output. You can see it mostly mimics the first one. We're off by a few spaces here and there, but we could fix that. If we were to put this back to spaces again, I think we'll get a closer approximation to what we had initially. Yeah, now they perfectly line up the first and third lines. Okay, so this is an adequate substitute for the first one, but we're not really dealing with the spacing problems like we attempted to with the tabs. So how can we address that? Well, besides the parameter number, we can also embed in here spacing information, such as comma, and then how we wish to space it. Let's just say we want to left justify this, or we could right justify it. We could say left justify, and we'll have it use 7 characters. Then we can get rid of these spaces here. And by the way, left justify would be negative, not positive. Let me explain that. Positive numbers are used to right justify. So if the value you're substituting doesn't match that number, it fills in spaces in front of that value until it matches that number. So if I did a positive 7 here, 1, 2, 3 is what x is, but it's saying I want to justify using 7 characters. Well, there are 4 characters missing. So because it's positive, it's going to do space, 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 then 1, 2, 3. But if I want the numbers to be lined up on the left margin, I will use negative 7. It'll still use the 4 spaces, but they'll come after the 1, 2, 3. So if I were to run this again, you will see there is no difference in the output because it put those 4 spaces right here between 1, 2, 3 and then the next value, which is 123.456. What about the second value? Well, in this case, we probably want to do right justification because of the decimal nature of the number. Usually when you line up currencies or some decimal values, you want them to line up over their decimal places. Now, using just a comma and then we want it to use a total of so many spaces. Currently it's taking up 7 plus the additional 4, after it or the 4 before it, depending on how you look at it. So it's going to use a total of 11 spaces. So I could make this 1, 11, and then I could get rid of this first one because a positive 11 is going to put the 4 spaces ahead of our value. If I did negative 11, it's going to put them after. In this case, because I want to do right justification, I'm going to keep it with the positive 11, and then I could eliminate this one on the left-hand side, or the first parameter, and I hit run, and you can see I'm still accomplishing the exact same output, except now I move the burden of the spacing issue to the second parameter instead of the first one. The first one's just going to output just 0 by itself. This is not going to be the final form of how we do it. Okay, this is just trying to emulate what we currently have. Then finally we have this date time, which is going to have 4 spaces followed by whatever date we print. Now this one's going to pose a particular problem for us because we have no idea how big this date string is really going to be. And because it's left justified, well, we have that other issue as well. So we could just leave the 4 spaces in here and call it a day. But we really didn't accomplish what we were trying to do by using these spacing values to line up our text. To really get to the spot we're comfortable, we're going to have to use some other techniques along with the spacing to get things to line up the way we want. And here we'll probably leave the formatting we accomplished with the first output based on what we think the ideal output should be. So let's take a look at another example. And we'll just leave this one behind for right now. And we'll use different variables in place of the x, y, and dt. Let's create something that's a little more practical in the real world. We might have someone's ID equal to 1 through 9. We might have their name, or maybe we'll have last name and first name. How does that sound? We can make this fairly complicated if we like. Last name, and we'll say Smith, string first name equals James. Then we could have double salary equals, makes pretty good money. And then we'll have his date of hire. Date time, date of hire is equal to, I'm going to copy this parse statement from the top. Let's say old James here was hired on March 15th, 2015. I accidentally deleted the first quote. Now we want to print this out. And as you might guess, we're going to have other employees that we're going to print their information out as well. So let's create an output we'll call string.format. And you'll see I'm going to employ a couple different new tricks in here. First, let me lay it out the way I want the output to look, and then I'll walk you through what I'm actually doing. I have to supply all of the variables, ID, last name, first name, salary, date of hire. So you can see I have a mix and match of the spacing and this new thing with this colon and some weird symbols after it. Well, and then in some instances I have both. This colon and everything after it is going to specify not the spacing of the data I'm formatting, but how to format that actual data. So let's look at each one individually and walk through what it's actually going to do. So the 0 parameter, that's the first one we're doing, corresponds to this ID. And what I'm telling it to do is to format the number using this output format, where for every digit going right to left, where there is a corresponding digit, it puts it in place of where the 0 is. If I run out of digits, let's say this was only 1 through 7, so it's going to have a digit here for 7, 6, 5, 4, and then it puts literally a hyphen, then 3, 2, then 1. Actually, I only want 2 numbers in here. 3, 2, and 1. I have 2 of these zeros left over, so it's going to literally put 2 zeros there. If this looks familiar, it should, it's a Social Security number format. So that's how I'm going to format this integer. This is known as a custom format string for numbers, where a 0 is a placeholder for a digit, and if the digit is missing, it'll literally put a 0. Otherwise, it puts the digit as it finds it in the actual data value. I could also use a pound sign. It's another placeholder, but instead of substituting the digit with a 0, it's going to substitute just wherever it finds the pounds, and if it finds digits that don't belong there, it doesn't inject any extra characters. So no zeros will show up when a pound is there and a digit is not found. Then we have the next two, which are simple string with spacing information. So last name corresponds to the 1. We are saying use left justification because it's negative and consume up to 15 spaces. So it'll take Smith and then inject another 10 spaces. Then first name, that's this one here, it'll again use 15 spaces total. So it has James. Again, it's going to inject 10 trailing spaces after James. Then we have this one, which is a combination of both spacing, indicating we're going to use 12 total digits, right justified, or 12 total characters, and then this :C. And if you're going to use both, it has to be in this order: parameter number, spacing, which is following the comma, and then formatting. Unlike the other numeric format we used, which was a custom format we created, we're telling it to use one of the predefined formats. In this case, it's called currency, the C value. C is going to take that double, that salary value, and format it to the local region's currency, in this case, American dollars. So we'll have a leading dollar sign and commas separating the thousands, and we're also going to have 2 decimal places. And we may fiddle with the 12 if we decide that's not the right number to use. Then finally, we have 4, which corresponds to date of hire, DOH, and it is going to use a specific format, a custom one, for dates. In this case, it's going to print out the 4-digit year, then it's going to have a hyphen, and then we'll have 2 digits for the month, and if the month is a single-digit value, like anywhere between January and September, 1 through 9, it'll pad a 0 in front of it. If I didn't want the 0 padding, I could just supply a single M. But the second M is going to tell it to use 0 padding. And the exact same thing happens when we format the day of the month, which is going to be the 15th. If it was the 5th, then it would put a 0, 5. If I don't want 0 padding, I make it a single D. But I do want 0 padding. So now let's print out output again by copying this console write-line command. And you'll see the output. We have our Social Security layout, last name, bunch of spaces, first name, bunch of spaces. Then we have a salary, followed by the date of hire. Let's count the digits in salary and make sure 12 is enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is good for up to this. However, if we made, instead of 6 digits, 7-digit income, it would jump from, basically we're using 11 digits here, it would jump to 13 because it's going to inject another comma. So I think we need to change this from 12 to 14 just to cover our CEO salary. Then, if we want to do another person, we can copy all of those variable assignments down here, get rid of the type name in front because we can't redeclare the same variable. We're just going to reuse the same variables. And this time we'll give different values for the names. And then the salary, so she'll be the CEO. And she'll make $5 million and change. And you know what? I'm going to put 3 digits on the end so you can see what happens when it formats as currency. And then we'll use a different date. We'll calculate the output again, and we'll run this one more time. As you can see, we have the IDs, they're lining up nicely, even though we have 2 extra digits for Sally. Remember, because of the 0 replacements in James's ID, they line up perfectly. Then we have last name, followed by first name. And then you can see the currencies line up still. We have nice lineup over the decimal places and the commas. Because Sally makes a lot more money, she has a little bit more here on the left, but everything is still lining up on the right nicely, and the dates also line up nicely. Now, as you notice, some of these outputs did not require spacing information explicitly. Like the date, we did not supply spacing information, and the Social Security number, their ID, did not have any spacing information explicitly. And the reason is because we're forcing it to use this format here, where we're saying it's going to consume this many characters. It's going to have 11 characters because we have the 9 digits plus the 2 hyphens. So it's always going to consume the basically 11 characters. And likewise, the date is always formatted to use these 10 characters, the 4-digit year, the 2-digit month, 2-digit day with 2 hyphens. The other ones, because the size is going to be variable, that's when we specify the spacing information as well. Now, as far as what the different format strings are, that is something that you need to look at MSDN for help. To find the specific formats you can use for different data types, go to Help for the string.format command by hitting F1 on Format. It should take you to either your local help pages or the online version of MSDN. Then you're going to need to scroll down a bit. I'll try to get us there pretty quickly, where it starts talking about formatting in this format string. And you can see here it talks about all integral and floating point types. See standard numeric format strings. So I can open that in a new tab, and then you can see standard number format strings, and it shows you C is for currency, D is for decimal, and then it'll show you all of the different predefined types, and then you can also go back and look at the custom number format strings. And here it shows you that what I was talking about earlier with the 0 placeholder and digit placeholder, decimal places, you can inject literal characters. So it'll walk you through the different codes you can use for numbers. The same goes for date times. You can look at the standard date and time at format strings or custom ones. I showed you a custom one because I was demonstrating Y, etc. And you can take a look at what each of those could be. So I can scroll down to the 4 Ys, and it shows it's the year. Not the 4, not the 5. It's the year as a 4-digit number, as opposed to a 3-digit number or a 2-digit number, or possibly even a 1-digit number. To avoid Y2K issues that we had several years ago, I just recommend sticking with the 4-digit one. You might say, well, maybe we should go to the 5-digit number now, just to be sure. I'm not so worried about what my software is going to be doing 7,000 years from now. So probably you're good enough just sticking with the 4-digit year. Considering how far computers have evolved in the past 100 years, since there weren't any computers really 100 years ago, I can't even fathom what they're going to look like, 7,000 years from now. So just stick with the 4-digit year for years. For months, we use the two M's, the capital M's, and that's going to show the month from 01 to 12. Notice the padded 0 here for the 1. And then we did the double digit day, DD, and that shows the day of the month. And you might wonder why the month was capital M's instead of lowercase m's, and that's because the lowercase m is used for minutes. So month and minute starting with the same letter, they had to pick one for uppercase and one for lower, and since the month is typically a bigger value than a minute, they went with capital M for month. So okay, let's print out Sally's information again. So we can see the output one more time. And let's see if we can improve on this format somehow. Well, we can intuitively guess that this ID is the thing that's up front, and then that's probably last name, first name, probably salary, maybe date of hire. What happens if we wanted to be explicit about that? Then we can do something called printing a header. A header is going to be just a string we output in front of those other results. And I'll put a console write line between everything so it doesn't interfere with each other. And I'm going to use a very similar technique to this output string. First, I'm going to say console write line. And I'll give you a little tip here. This actually, other than the fact that I'm using these variables, works without calling string.format first. Up until now, we've been saying string.format and putting the results into output and then explicitly passing that output to the console write line statement. We don't really need to do that. Console.writeLine will do the exact same thing as string.format, except instead of putting the output into a string, it puts the output directly to the console. So I want to use this as a basic template to what my header is going to look like. Since I know this is going to consume 11 characters, we've already discussed that because there's 3 plus 2 is 5 plus 4 is 9, and then we have the 2 dashes. So we know this 0 parameter, we want it to consume 11 characters. That should be 1 hyphen and 2 ones, not the other way around. We already know last name and first name are going to consume 15. We can leave those alone. Then this one is going to consume 14, which is the salary. And then this one is 10. And we'll put that one left justified. Then we just replace these variable names with corresponding strings for the headers. Then, to make things look even better, I'm going to do another console write line. I want to put some delimiter between my header and the actual tabular data. Typically, I do this with either a line of hyphens or a line of equal signs. We'll use the equal signs. We could do it like this. Nothing wrong with that. However, I have a nice, simpler mechanism where we could pass it a new string. It's a constructor for a string. And then if you slide down to the fourth constructor, you can see it accepts a character followed by a count. Well, the character I wish to use is equals, and let's see what the count should be. We have roughly 30, 40, 55, 65, 6, 7, 8, 9. Let's do 70. It's a good guess to start with. So that will output a new string with 70 equal signs. And sure enough, 69 would have been the appropriate cutoff, but it still looks okay the way it is. But now you can see we have ID with the ID under it, last name, first name, salary, and then hire date. So everything's looking really nice. And this is the start to making more complex tabular output. Clearly, if we had another value we wished to add to this, we might run out of screen space. If that's the case, we'd have to make the console window a little bigger. Here's what I mean. Let's put in a new variable called position. And we'll say he's technical lead. Okay, so James is the technical lead, and then we will put this here, 20 characters. I'm going to copy that here. And here's an excellent example of why we want to use a constant sometimes to avoid duplicate data like this. Take a look at what we did. We have this 5, 20, so I had to change it down here. If I forgot to do it, guess what? Sally isn't going to print the same. So let's finish the line here first of all. And I'll put position down for Sally as well. And when we try to run this, I mean, it'll work. I didn't change Sally's position. But as you can see, it runs off the end of the line and goes to the next one. So how can we fix that? Well, there are several techniques we can use. First, let's figure out how much space it's actually using. And we need to fix the header too. So that's going to be 5, -20. Not colon, that should be a comma because it's spacing, not formatting. And then we are going to say position. And this is going to have to be much bigger. Because 69 was the exact value we needed before, we just added 21 spaces because of the space between and then the additional 20 for the formatting. So we have 69 plus 21 gives us 90. Well, it looks like my console window is probably set up for 80 column width. So what I would need to do at the beginning of my console application is to check to see if the console, sometimes IntelliSense is not your friend. We have largest window width, that's what I was looking for, is greater than 90. We will say console.windowWidth equals, let's say 91. Maybe we'll say greater than or equal to 91. Why did I add the extra one? Because if you use all 90 characters and it's exactly 90 in width, it'll still give you the carriage return whether you like it or not. So I always make sure I have at least one extra character. Now if we run this, you can see we have that one extra space here, but everything still fits. Oh, we need to change Sally's position to CEO. To be correct. As I mentioned, we don't want to keep repeating this in line like this because if we make changes, you saw what happened. I have to make the exact same change in both places. If I start adding 5 or 6 more of these, well, you can see where that would be a problem. So what I usually like to do then is I'll define this as a constant. I'll say const string fmt is equal to that. And then I'll put format fmt in place of it. And then I can bring everything back on the same line again. I think it just makes it look cleaner. Clearly, again, I could create a new method to do the formatting and output of my employees. And I can also get rid of this intermediate step of the string format. I'll do that in the second one and just take all of this and put it here in console write line. Because remember, console write line will do string.format for us when it sees input like this, where the first input's a string and then a list of other parameters. Let's run this again, and you should see no difference other than the fact that Sally's position is now CEO the way we wished it to be. So string.formatting is extremely powerful. However, this format string is still kind of clunky because if you make any changes to your variables or you need to change the positions, you have to keep this in lockstep. So the 0 parameter for the ID should line up with ID, and then the 1 should line up with last name. We end up running the risk of using an index that doesn't exist, like we might have a 6 here. Watch what happens if I try to do a 6. You'll see we get a format exception because we tried to use an index that's not one of the values being passed. So I have to put that 6 back to a 5. So it's very powerful, but at the same time can become very complicated quickly. With C# 6, however, Microsoft added a new technique called string interpolation. And string interpolation is going to do something very similar to string formatting, except we don't have to use these curly brace 0 parameter numbers. We can use the variable names directly in the format string itself, which solves a lot of the complications with outputting these values and lining up the format and the parameter number with the thing you're actually trying to format. Now, this technique will only work with Visual Studio 2015 and above, so if you're on an earlier version of Visual Studio, this is not going to work correctly for you. So how could we do the exact same thing? We'll just print out Sally's information one more time using string interpolation. Okay, we could copy this as such. Actually, I want the whole thing. Then I could say output is equal to this string, but in front of the quotes, I'm going to put a $sign. Now, let me take the $sign off again. Watch what happens to the coloring of the curly braces and the values inside. Without the $sign, it's just all red text. C# doesn't know anything about this. It's not a special string at all. But as soon as I put the $sign in front, it starts to look and say, oh, look, that's a parameter and this is a format string. See how that became red, but everything else is black? Oh, that's a string, so that's red. Oh, that's a string, so that's red. So it's actually looking for different values now inside these curly braces. But as I said, we don't need to use 0, 1, and 2 and then a comma, ID, last name, first name. I can directly in here just type in ID. And you can see IntelliSense is working as well. For 1, we knew that was last name. For 2, that was first name. And again, IntelliSense is popping up as soon as I start to type. Then we had this as salary. This was date of hire. And then finally, we have position. Now the downside is this does take up a little more space because everything's in line. You don't have the format string followed by a list of parameters, but I would say this is now a lot easier to read because you don't have to line up 0 with ID, 1 with last name, 2 with first name. You use the value directly here. And you can use anything that's local in scope, or visible in scope, I should say, at this position. The reason the code was working before, when it still had a 0 here, was because it was interpreting this literally as the constant 0, and it was going to format 0 using this format string. Likewise, it was going to use the value 1 and left justify at 15 characters, etc. down the list. It was probably going to run into a problem here when this was a 4, and it tried to format a 4 as a date. That was probably not going to work too well. But for all the other ones, we probably could have left them alone. So when we have this output, then we can call console writeLine, and we run this again, and you see the exact same output. Could we have done that in one line? Absolutely. All we need to do is do the console writeLine, and then copy this information here as such. And then we can eliminate the need for that intermediate temporary variable output. And we should get Sally now printed a third time. So the string interpolation technique is probably the way you wish to go if you have access to the latest C# compiler, at least C# 6, using Visual Studio 2015, because in a lot of ways you get the exact same power as string formatting without all of the headache of lining up parameter numbers to the actual parameters.